first of all, we're going to prove true for n equals 1. Now, what we're actually trying to prove is this statement. 1 plus alpha to the n on 1 minus alpha to the n, where alpha is minus a third. Okay, and we're going to use this sequence and this statement up here to actually do it. So we're going to prove for n equals 1. So if we did n equals 1, x to the 1 will equal 2 times 1 plus alpha to the 1 over 1 minus alpha. Now alpha equals minus a third, so we'll put minus a third there, and that's 1 minus minus a third. So that's 2 times 2 thirds over 4 thirds, which equals 4 thirds over 4 thirds, which equals 1. Okay, now we're going to assume true for n equals k. So we're going to assume that x to the k equals 2, 1 plus alpha to the k over 1 minus alpha to the k. And then we're going to prove for n equals k plus 1. So x to the k plus 1 equals 2, 1 plus alpha to the k plus 1, all over 1 minus alpha to the k plus 1. So if we start off with this and we look at the left-hand side is x to the k plus 1. Now if we go and we use the sequence that's up above there, then that means that will be 1 plus x to the k over 1 plus x to the k. 4 plus x to the k over 1 plus x to the k, because you're just replacing the n with a k. Okay, now if you look at, if you get that then and you're simplifying that, so you go left hand side equals 4 plus x to the k. Now x to the k from our assumption is that there, so it's 1 plus alpha to the k over 1 minus alpha to the k over 1 plus x to the k, so we're going to grab that again, so it's 2, 1 plus alpha to the k over 1 minus alpha to the k. Now if I simplify that, I'm going to times the top of the bottom by 1 minus alpha to the k. And if I do that, you get 4, 1 minus alpha to the k, plus 2, 1 plus alpha to the k, all over 1 minus alpha to the k, plus 2, 1 plus alpha to the k. Because when you multiply this, that one goes times the 1, and when you times that, they'll cancel. That goes times the 4, and that's why you get that. And when you go that times that, they'll cancel, and that's why you're just left with the top. So expanding the top, you get 4 minus 4 times alpha to the k plus 2 times alpha to the k, all over 1 minus alpha to the k plus 2 alpha k. Okay, so if you now collect the like terms here, we have 4, 6, so you have 6, let's write this up here, so you have it equals 6 minus 2 alpha k, and on the bottom we have, that was a 1, 3 plus alpha k. Okay. Now, what is our prize? So I'm just going to write out xk plus 1. xk plus 1 is 2, 1 plus alpha to the k plus 1 over 1 minus alpha to the k plus 1. So how is that the same thing? You know, that's what we're just going to look at. We have the 2, and we have 3 minus alpha to the k over 3 plus alpha to the k. So it's very close because you can see the 2's match up. So the difference must be in the alpha. So if I now go, alright, the right-hand side, which equals 2, 1 plus alpha to the k plus 1, which is this here, I write it as alpha to the k times alpha. And here I have 1 minus alpha to the k times alpha. Now if I replace that alpha with what it's actually equal to, which is minus 1/3, then what happens here? So if I get that alpha, and I go 2, alright, and I go 1 plus alpha to the k times minus 1/3, and we put that over 1 minus alpha to the k times minus 1/3, then we have the third as a fraction on the bottom, so it's 2, 1 plus alpha to the k times minus 1/3, and then 1 minus alpha to the k times minus 1/3. So if I times the top and the bottom by a 3, you end up with 2, and you get 3 plus. Now that minus there will come to the front and be minus alpha to the k, and on the bottom you go 3 times that and then 3 times that, so you get 3 minus. Now this is minus 1/3, so that minus goes with that minus and makes it a plus, alpha to the k. Now if you look at what we're trying to get on the left-hand side, it is now the same thing. So that equals the left-hand side proven, and therefore you can just go by the process of mathematical induction, true for all n greater than or equal to 1. We want the limiting value of xn as n goes to infinity. So minus 1/3 to the power of n, because it's a fraction less than 1, the denominator will just get bigger and bigger. And minus 1 to the n will just keep changing signs. So as n goes to infinity, like the 3 to the n will go to infinity. Therefore the minus 1 over n, 3 to the n, will go towards 0. So that means the x to the n will go towards 2 times 1 plus 0 over 1 minus 0, which just equals 2 times 1, which is 2. So the limiting sum of this expression is 2.